Hi everyone, Alex Tardy, meteorologist with Weather Echo, 32 years at NOAA National Weather Service. Lived in California for 20 years, grew up in Vermont, and I've worked in many places like Texas, Utah, Northern California, Virginia. This is our winter weather outlook. This is our latest weather insight. So put on your seatbelt. A lot of information. We know El Nino's the big topic, and we're going to talk about that and more. All right, let's get going. These are the highlights. The target zones of western U.S., but in reality, most of the U.S. and the globe, the Earth, is affected by El Nino in some ways. That's drier, wetter, colder, warmer. This is extreme El Nino potential coming up. Already the El Nino is developed, so put that on your checklist as done. It's here. Now it's a matter of how strong it is and what the impacts are. So we can see it on satellite and we'll show that. El Nino is normal. It's a warming along the equator of the ocean sea surface temperatures. But it is an anomaly. So it's not always there. It's every 3 to 5 years. El Nino is not a storm. So cross that off your list. It's not precipitation. It's not a weather pattern. We'll talk about that. The last very strong El Nino was just a few years ago, 2015-16. And guess what? That was below average in Southern California. Average most of the state. So the two wettest years were La Nina. Just a couple years ago, 22-23 and 2016-2017. So yes, after that El Nino, that was a bust of 2015-16. El Nino wasn't a bust. It developed. It was very strong. The storm track or the jet stream was primarily over the Pacific Northwest and Seattle. So it was a ball, not a strike. But El Nino was there. So a lot of times there are people say there was no El Nino that year. That's completely false. That's not understanding El Nino. El Nino is not a storm or precipitation or weather pattern. El Nino does bring more energy from the tropics, okay, from the unusually warm water. So the atmosphere likes that. Warm air rises, becomes more buoyant, and also warmer air can hold more moisture. El Nino warming effects are global and also affects jet streams globally. Now, in the Pacific, we normally have a very strong jet stream, especially in the winter when the sun angle's low. You have that contrast between warm in the tropics and colder in the polar regions. But you add warming in the tropics, you have an elongated, extended, consolidated jet stream, and that's the pattern that evolves often and typically during El Nino. But where that jet stream sets up is most prevalent is the wild card. Now, that extended Pacific jet stream, if you get into that storm train or that track, you can see excessive precipitation, storm after storm after storm. Where that storm track sets up is the key. It may only set up across Northern California for 2 or 3 weeks at a time, and Southern California misses out. Or it might set up over Oregon, or it might be over Southern California, not affecting Seattle at all. So the width of that is only several hundred miles wide. So in a perfect scenario, that storm track is like a water hose, and it fans the entire West Coast relatively evenly. But Mother Nature doesn't typically play that way. Okay, what have you done for me lately? So this past year was not an El Nino. It was very wet, though, in South Central California, Santa Barbara, LA County, as shown here. Much above normal, not just wet. Now, most of the West in the yellow here was below average or very much below average last year. So we're going from a dry winter previously for most of the West and a very poor, very low snow year. Now, what is El Nino? The recap here, 101. So normally the conditions are like this. You have trade winds going from east to west along the equator. That'll push hurricanes, tropical cyclones from west to east in the Pacific and in the Atlantic. But it also keeps the water built up and warmer to the west along the tropics. What happens is that area becomes overwhelming and pressure changes, then the wind shifts and that erodes and removes those trade winds, and that allows basically a dam break, and all that warm water shifts to the east and bangs up on the South America coast as shown here. Fishermen in South America noticed this first with changes in fish types and animals along the immediate coast. And again, it's every 3 to 5 years. It's a way for the ocean to relieve itself, shift warm water with colder water. And it's the opposite of La Nina, which is cold water surfacing. Okay. The weather patterns do the same thing. They relieve hot and cold, high and low pressure. And this is a way of the ocean doing that. Now, that ocean change or that warming and that release of energy and more moisture also will affect the jet stream. So remember, warmer air will rise, become buoyant. We call it convection. So currents start to lift and you get circulations developing in the Pacific as shown here. Well, one of those circulations become very enhanced in the East Pacific and team up with the normal jet stream and cause a phasing where you have a very consolidated, elongated jet stream. And with that jet stream is really the only way you're going to get storms and precipitation, at least in the West Coast. So the tropics can be very much an influence on our normal jet stream. How do we know El Nino is a slam dunk? Well, it's already here. Check that off your box. This is a satellite image. Basically, the satellite saying, okay, show me where the water is warmer or colder than it should be or on an average level, like 30-year average. And you can see it stands out like a sore thumb. El Nino is already here. So it's not a question of where, when, how. It's how strong and what will it do with the jet stream. It's already affecting the Atlantic Ocean with wind energy coming off those tropical warm waters, inhibiting tropical cyclones in the Atlantic Ocean, enhancing some of the tropical cyclones in the Pacific already. And we've seen south swells move up into Southern California with beach erosion from those hurricanes. So it's already having an influence, but when the sun angle gets lower and the jet stream starts to naturally lower and strengthen with cold air building over the poles because of lack of sunshine, you then start to see more of an influence, specifically December, January, February, March. The predictions, and these are off the charts. So the universities, the research centers, NOAA, they've had to redraw the scale here. I'm labeling this extreme. Okay, we have not seen an El Nino above 2.5, so we need a new category. And the predictions on average with my arrow here in midwinter are extreme, up around 3 degrees Celsius, which is a massive number considering we've never seen an El Nino stronger than an Oceania index of 2.5. And we'll show some of those numbers as well. So confidence, we know it's here. We expect it to expand and even strengthen a little bit more as we go into the fall and the winter, with all of these different computer models that are updated about once every month, indicating in that extreme category up around 3 to almost 3.5 Celsius. So that's a big number, okay? You're talking in that region, you can double that, get around 10 degrees Fahrenheit of warming, which is just a huge number in that area. Okay, all El Nino precipitation, take a look at it here. If you just took all the past El Nino years, we call these analogs, look at the precipitation, the blue and the green is where it was wetter than normal. So wetter than average, not just because it's winter, but wetter than average. And that's the East Coast, the Gulf Coast, and then most of California. With drier conditions, the Pacific Northwest, Ohio Valley. If you look at very strong, which is a good sample size, but not a lot, most recent 2015-16, you can see a large swath of the lower 48 is above average. So that means the jet stream was moving, prevailing from west to east across the lower 48 there. Now, if you look at the strong and very strong, smaller subset, you can see pretty much the same signal showing up, especially along the Gulf and Southern California. Now, if you look for temperature, notice, and this may be a surprise, the lower 48, especially the southwest to the southeast, it's cooler than average, not warmer than average, not more tropical, as you might expect, not necessarily higher snow levels, not more Pineapple Express, but all this precipitation cloud cover keeping temperatures down across those areas shaded in blue. So if you look at the very strong, which again is the small subset, Very warm conditions above normal show up in the northern plains, so lack of Arctic intrusion or polar vortex, and cooler due to the clouds and precipitation in the southwest. If you look at strong and very strong, which is a little more subset, as shown here, including the 2015-16, you get that same signal of lack of cold air, warmer conditions, lack of Arctic air in the northern plains and Great Lakes, and cooler, not because of Arctic air, but cooler because of precipitation and cloud cover from Southern California through Texas in the southeast, as shown here. Now, these are the past El Niños and La Niñas. El Niños in red. There's that big one in 2015-16 showing up clearly on here, and that was below average in Southern California for precipitation. So the relative oceanic Niño index was redefined in the past year, and so some of these numbers and values have changed. But the bottom line is we're still looking at a 3-month period. So for example, we look at December, January, February, March. We look at that 3-month period and rank the value in Celsius. You can see most recently there was an El Nino in 24. Then there was one in 2019, and then that big one in 2016. And then we also had, of course, the 94, 95 that was very wet, 98, 99. That's when we learned a lot and thought we knew all the relationships, but we didn't know everything, obviously, because 2015-16 was dry for most of California, even though it was very strong. And then look at this one here, 2.5. So there's the big one now in this new scale, 2.5 there. And that's 82, 83. That was very wet across the western U.S. Precipitation in general, though, across the western U.S. is variable, even without La Nina or El Nino. It's really up and down from very dry years, normal years, to very wet years, as shown here. So precipitation forecasting in the long range is difficult in general in the west. You have to be in the storm track in that jet stream, and if that jet stream is missing you just by a few hundred miles, you can be very dry. If you're in it and it's persistent for weeks or even months at a time, you're very wet. Two of the most recent La Ninas, yes, La Ninas, were amongst the wettest, so they made the top 10. Now, you may be surprised for this, Sierra Nevada, okay, precipitation, so rain and snow. The wettest year on record is La Nina, 2016-2017. The El Nino year of 82-83 is right below it. Now, the snowiest year, not counting rain, just snow, was actually just recently in 2022-23, which was also a La Nina. So here's it broken down in the west, top wettest years. Of course, El Nino's the winner up top. But La Nina shows up in the top 10 across the entire West. And of course, even in California, La Nina shows up in the top 10 as shown here. And the most recent one, 22-23, at the very bottom is shown on here as well. So the bottom line is, yes, El Nino has mostly produced the top wettest years in the West and in California. But we've seen some huge amounts and anomalously wet years also with La Nina. So there's still variability. All the computer models that put long-term predictions, which are difficult beyond 3 weeks, to say the least. It's really hard to predict storms and weather beyond 3 weeks. But the models that try to do it for December through February shown here, they're all blue shaded, focused on California and the Southeast and the East Coast. So that is pretty high confidence of wetter than average conditions in the winter for those areas. Now, if you look at temperature, again, because of the clouds and precipitation across the south, the warmer water streaming up, combining with the marine heat wave that's already ongoing. Okay, we already have warm temperatures that have got up to 77 in La Jolla, where there's over 100 years of data. But when you start, as we're seeing now, the ocean from El Nino combining with that marine heat wave, that'll result in, yes, warmer temperatures even during the winter streaming up along the west coast as shown here. But with all the cloud cover inland and precipitation, cooler temperatures. And really all the models are showing that as you see here in the blue shaded. Now, if you break it down month to month, we're heavy in the monsoon here in August, and that's expected to continue in September with heat and monsoon pretty widespread, above average. Then we get the break as we go transition to Santa Ana season, okay, and the atmosphere potentially starts feeling the effects of El Nino. We start seeing the storm track getting active maybe late November and certainly December, and peaking out in January, February, not shown here in March. So our wettest months normally across most of the West are January, February. And so you make an enhanced, elongated, extended jet stream, basically a more powerful jet stream, more focused jet stream. If you're in that jet stream, you could be very wet. Not just atmospheric rivers, all types of storms. This is the expected projection of the storm track or the jet stream or the weather pattern. Again, El Nino's not the weather pattern, but it affects, influences, and can modify the weather pattern as shown here, bringing the normal jet stream further south into central California and then swinging up into New England. That allows the Gulf to be open for business with lots of rain and winter storms along the East Coast, and also storms tracking across Texas, as well as the epicenter of storms tracking somewhere across California and including in southwest Oregon, as shown here. So those areas are expected to not just be wet because it's winter, but much wetter than normal. If you look at temperature, we talked about this extensively. Cooler and cloudier for the south. Warmer along the west coast. Not warmer for higher snow levels, but warmer along the immediate coast because we've got warmer ocean temperatures from that marine heat wave combining with the warm El Nino. And we've got less Arctic polar air. A lot of that polar air is shifted further north and not allowed to penetrate into Hudson's Bay, as shown here. So you get milder, warmer conditions in eastern Canada. Okay, so really you've got kind of an inverted pattern, what you normally see, making this, abnormal. Hope you enjoyed this weather insight. We'll update as we go through September, October. You can find real-time information on Threads and X, shorter video clips on TikTok and YouTube as well. And of course, weatherecho.com with a full-blown El Nino page on there. And we also have a blog that you can sign up for to get heads up, such as a active storm track in 2 to 3 weeks type of information being posted as a video, as a short video, or being posted as a full blog on our page. Okay. Yes, I've bought my ski pass, the icon. That's me at Palisades Tahoe last May. Everyone, stay tuned. Hope you learned a little bit about El Nino, that it's not a storm and precipitation, but it influences and affects the global jet stream weather patterns, which can bring warmer, wetter conditions, but also colder, drier conditions in other parts of the earth. So stay tuned for more information, everyone. Be safe. Now's the time to prepare if you're concerned about flooding or other type of impacts, no matter where you live in the United States. All right, take care, everyone.